For nearly a century, the story of Tutankhamun seemed complete. A boy king, crowned at 9, dead by 19, buried beneath the Valley of the Kings with more than 5,000 artifacts sealed around him. His golden mask became the face of ancient Egypt. His tomb, discovered in 1922 by Howard Carter, became the most famous archaeological find in history. The family behind him, the dynasty that shaped his world, that question was considered settled. Amenhotep III and Queen Taye were the grandparents. Akhenaten, the heretic pharaoh who dismantled an entire religion, was the father. The mother, some assumed Nefertiti, others a lesser queen named Kia. Reasonable guesses, supported by inscriptions, temple records, a few carved names. Then, in 2010, a team of Egyptian scientists extracted DNA from Tutankhamun's bones, and what they found didn't just fill in the blanks. It erased several of them and rewrote the rest. The mother of the most famous pharaoh in history was not who anyone expected, and the family tree behind him, once you see its shape, tells a story far darker and far more consequential than any golden mask. But to understand what the DNA revealed, you first have to understand what everyone thought they knew and why they were so confident about it. The 18th dynasty of Egypt spanned roughly from 1550 to 1292 BC, a period historians call the New Kingdom. It was Egypt at its peak, an empire stretching from Nubia in the south to Syria in the north. Amenhotep III, Tutankhamun's grandfather, ruled for nearly 40 years. He built monuments across the Nile, maintained diplomatic marriages with foreign kingdoms, and presided over what many consider the wealthiest era in Egyptian history. His queen, Taye, was unusually powerful, depicted at the same scale as the pharaoh himself in temple reliefs, something almost unheard of. Their son, Amenhotep IV, would change his name to Akhenaten and trigger a religious revolution. He abandoned the traditional pantheon of gods, shut down temples, relocated the capital to a brand new city called Akhenaten, modern-day Amarna, and declared that only one god existed, the Aten, the sun disk. It was radical. It was unprecedented, and within a generation, it was undone. When Tutankhamun came to power, still a child, the old order was restored. Temples were reopened, and the capital moved back to Thebes. Even his name was changed, from Tutankhaten, living image of the Aten, to Tutankhamun, living image of Amun. The old gods were back. And then, around 1324 BC, the boy king died. He was 19. For decades, historians debated who exactly Tutankhamun's parents were. Several inscriptions from his reign refer to Amenhotep III as his father, but in ancient Egyptian that term could also mean grandfather or ancestor. The word was imprecise. Akhenaten was the leading candidate for his biological father, but the mother's identity was genuinely uncertain. Nefertiti, Akhenaten's great royal wife, was famous, powerful, and the mother of 6 known daughters. But no inscription explicitly names her as Tutankhamun's mother. Another candidate was Kia, a secondary wife of Akhenaten, mentioned on a handful of monuments and then conspicuously erased from all records. There was also the theory that his mother was an unnamed princess, perhaps one of Akhenaten's own daughters. The archaeological record offered fragments, not answers. And then there was the mystery of the mummies themselves. In 1898, archaeologist Victor Loret discovered tomb KV35 in the Valley of the Kings. Inside, alongside the mummy of Amenhotep II, were 2 unidentified females. They had been stripped of their wrappings and laid unceremoniously on the floor of a side chamber, hidden there perhaps by priests 1,000 years after their deaths. One was older, one younger. They had no names, no labels, no coffins bearing inscriptions. They became known simply as the Elder Lady and the Younger Lady. For over a century, they remained anonymous. Then there was the enigma of tomb KV55, discovered in 1907. Inside was a single damaged coffin, its golden face ripped off, every personal name deliberately hacked away in antiquity. The mummy inside was badly deteriorated, reduced nearly to a skeleton. The coffin had originally been made for a woman, then modified for a king. Canopic jars nearby belonged to Akhenaten's secondary wife, Kia. Magic bricks bore the name of Akhenaten. But the body inside, how old was it? Anatomist Grafton Elliott Smith examined the bones in 1908 and concluded the person died in their early 20s. That was a problem. Akhenaten reigned for at least 17 years and likely fathered children in his first year of rule. He couldn't have been only 25 at death. So if the KV-45 mummy was too young to be Akhenaten, could it be someone else entirely? A shadowy figure named Smenkhare, who appears in a handful of inscriptions and then vanishes from the record? This was the knot Egyptologists had been trying to untie for 100 years. Multiple candidates for every role, fragmentary inscriptions that contradicted each other, mummies without names, names without mummies, and the tools available, X-rays, physical measurements, stylistic analysis of art, could only take them so far. What no one had ever done was test the DNA. In September 2007, a project began that would change everything. Zahi Hawass, then head of Egypt's Supreme Council of Antiquities, authorized what became known as the King Tutankhamun Family Project. It was, at the time, the first genetic study ever permitted on Egyptian royal mummies. 2 dedicated DNA laboratories were built from scratch, one in the basement of the Egyptian Museum in Cairo, 2 floors below Tutankhamun's Golden Mask, and a second at Cairo University's Faculty of Medicine. The separation was deliberate. Every result from one lab had to be independently replicated by the other. The lead geneticists were Yahia Gad and Somaya Ismail from Egypt's National Research Center. Paleogeneticist Karsten Pusch from Germany's University of Tübingen joined them. Working with ancient DNA is not like running a modern paternity test. The double helix inside a 3,000-year-old mummy is shattered. Egypt's heat, the humidity inside sealed tombs, and the natron salts used during mummification all attack the molecular bonds that hold DNA together. The fragments that survive are tiny, often damaged, and surrounded by contamination, bacteria, fungi, and the DNA of every archaeologist who ever touched the specimen. To extract anything usable, the team drilled into the dense cortical bone of each mummy, typically from the femur or tibia, sometimes taking 3 to 6 separate samples from different body areas, to confirm results were not artifacts of contamination. They amplified 16 short tandem repeats, STRs, the same kind of genetic markers used in criminal forensics and modern paternity testing. These STRs are regions of the genome where a short DNA sequence repeats itself, and the number of repeats varies between individuals. Compare the repeats between 2 people, and you can determine whether they share a parent-child, sibling, or grandparent relationship. It's the same science that identifies suspects from a crime scene or confirms biological fatherhood in a courtroom. The team ran these markers across 11 royal mummies spanning 5 generations, from Tutankhamun's great-grandparents to the 2 tiny bodies found sealed in his tomb. Before we see what this evidence reveals, if you're finding this investigation as fascinating as we are, subscribe so you don't miss future stories like this one. Now, the results arrived in stages, and each one tightened a thread in the web. First, the grandparents. DNA confirmed that the elder lady from K535 was indeed Queen Tiye, wife of Amenhotep III. Her mummified parents, Yuya and Thuya, whose tomb had been discovered in 1905, matched as expected. The grandparental generation locked into place. Then came the father. The KV-55 mummy, that controversial skeleton in the faceless coffin, was confirmed as a son of Amenhotep III and Tiye. And more than that, the STR profiles showed he was, with near certainty, Tutankhamun's father. The same team's CT scans also revised his age at death upward, finding degeneration in the spine and osteoarthritis in the knees. He had died closer to 40 than 25. The earlier anatomical estimates, it turned out, had been thrown off by the skeleton's poor condition. If the body was closer to 40, the gap between its age and Akhenaten's known reign of 17 years suddenly made sense. The KV-55 mummy, the team concluded, was almost certainly Akhenaten. But the real shock was the mother. The younger lady, that anonymous mummy stripped of her wrappings and left on a stone floor in KV-35 for 3,000 years, was Tutankhamun's biological mother. Her DNA matched. She was, without question, a daughter of Amenhotep III and Ta, which meant she was Akhenaten's full sister. Tutankhamun was the product of a brother-sister union. This was not merely an academic revelation. It rewrote the biological story of the most studied pharaoh in history. The team's geneticist Karsten Pusch put it plainly. He was not a proud pharaoh or a strong leader. He was a young boy, frail and weak. He could not walk by himself, and he needed other people or walking sticks because of bone necrosis. The evidence was visible on his body. New CT scans revealed that Tutankhamun had a congenital clubfoot, the left foot turned inward. One toe was missing a bone entirely. The bones in part of his foot were destroyed by Kolar disease too, a rare condition where poor blood supply causes bone tissue to die. Both the deformity and the disease would have made every step painful. Suddenly, something that had puzzled Egyptologists for decades made perfect sense. Inside Tutankhamun's tomb, Carter had found 130 walking sticks. Some were ornamental, but many showed clear wear from use. They were not symbols of authority, they were medical aids. Genetic screening detected DNA from Plasmodium falciparum, the parasite that causes malaria tropica, the most lethal form of the disease. It was found not only in Tutankhamun, but also in his grandmother Ta, his grandfather Amenhotep III, and the KV-35 younger lady. Malaria was likely endemic in the royal household. Tutankhamun, already weakened by genetic disorders from inbreeding, already walking on a damaged foot, may have suffered repeated bouts of the disease. His tomb also contained a kind of afterlife pharmacy, seeds, fruits, and medicinal leaves bundled alongside the golden treasures. The researchers proposed that a sudden leg fracture, evidence of which had been found in a 2005 CT scan, combined with an active malaria infection, could have triggered the cascade that killed him. Now the story deepens further. Inside Tutankhamun's tomb, Carter had found two tiny coffins, placed in an undecorated wooden box in the treasury. Inside each was a mummified fetus. One, designated 317A, had died at roughly 25 weeks of gestation. The other, 317B, had survived to approximately 36 weeks, near full term. Both were female. Both had been carefully mummified and wrapped in the same high-status style as adult royals. The smaller one even had a gilded face mask. Who were they? DNA testing confirmed Tutankhamun as the father of both, with probabilities exceeding 99.97%. The likely mother was a mummy from tomb K521, tentatively identified as Akhenaten, Tutankhamun's only known wife, who also happened to be a daughter of Akhenaten and Nefertiti, which means she was most probably Tutankhamun's half-sister. 2 generations of sibling marriage, 2 stillborn daughters, a teenage king who could barely walk. The DNA was not just revealing a family tree, it was documenting the biological cost of a dynasty consuming itself. But not everyone accepted these results. Within months of the JAMA publication, a wave of criticism came from some of the most respected names in ancient DNA research. Eske Willerslev, director of the Center for Geogenetics in Copenhagen and one of the world's leading authorities on ancient DNA, co-authored a letter to JAMA expressing deep skepticism. His primary concern was the methodology. The Hawass team had used a PCR-based approach, which amplifies specific DNA targets. The problem is, PCR can amplify everything, including contamination. In ancient specimens, where authentic DNA may be a tiny fraction of the total genetic material, PCR can easily amplify modern human DNA that contaminated the sample through handling, storage, or even airborne particles in the laboratory. Willerslev and others argued that next-generation sequencing, a newer technology that reads all DNA fragments in a sample indiscriminately, would have been far more reliable. Next-generation methods can distinguish ancient DNA from modern contamination by looking at patterns of chemical damage that accumulate over millennia. The Hawass team's approach could not do this. There were other concerns. Egypt's hot climate is particularly hostile to DNA preservation. The sodium carbonate used in the mummification process actively degrades genetic material. Some researchers questioned whether usable human DNA could survive 3,000 years in Egyptian tombs at all. A 2017 study at the Max Planck Institute managed to extract ancient DNA from Egyptian mummies using next-generation sequencing. But those specimens came from a cooler, drier site in Middle Egypt, and even then, the results were partial. The most pointed critique concerned the family tree itself. The DNA showed that Tutankhamun's parents shared an extraordinarily high number of alleles, 11 out of 16 markers, which the team interpreted as a full sibling relationship. But Marc Gabold, a French Egyptologist from the Université Paul Valéry Montpellier III who has spent decades studying the Amarna period, offered a radically different interpretation. Speaking at Harvard University, Gaboldi argued that the genetic overlap could be explained not by a single brother-sister pairing, but by 3 successive generations of marriage between first cousins. After 3 rounds of cousin marriage, the accumulated genetic similarity between 2 individuals begins to resemble that of siblings. He explained that the consequence of that is the DNA of the 3rd generation between cousins looks like the DNA between a brother and sister. He said he believes that Tutankhamun is the son of Akhenaten and Nefertiti, and that Akhenaten and Nefertiti were cousins. If Gaboldi is correct, the entire family tree reshapes. Nefertiti, the most famous queen of ancient Egypt, becomes Tutankhamun's mother. The anonymous younger lady loses her central role. And the incest narrative, while not eliminated, becomes considerably more complex, a pattern of cousin marriage extending back generations rather than a single shocking sibling union. Gabold's theory also explains something the sibling hypothesis cannot explain: why no inscription, no temple relief, no letter ever names a sister of Akhenaten as a queen or royal wife. Nefertiti, by contrast, is everywhere. Her name, her image, her titles fill the archaeological record. The KV-55 mummy itself remains stubbornly controversial. While the 2010 study aged the body at 35 to 45 years, supporting its identification as Akhenaten, earlier estimates consistently placed it in the early 20s. Multiple anatomical studies, from Grafton Elliott Smith in 1908 to Douglas Derry to Ronald Harrison, concluded the bones were too young for Akhenaten. A 2016 meta-analysis by Habicht and colleagues in the American Journal of Physical Anthropology noted that age estimation methods for mummies have been shown to carry significant error margins, citing blind tests on skeletal remains of known age from Christ Church Spitalfields in London, where experts frequently misjudged age by a decade or more. If the KV-45 body really did die in its 20s, it might not be Akhenaten at all, but someone else entirely, perhaps the phantom figure Smenkhkare, about whom almost nothing is known. And there is one more unresolved problem. The Egyptian government has never permitted samples from these mummies to leave the country. No independent external laboratory has replicated the results. In the world of ancient DNA research, where contamination is the constant enemy and replication is the gold standard, this is a significant gap. The data has been published, but the physical material remains under a single government's control. So where does this leave us? Today, the mummy of Tutankhamun still lies in his tomb in the Valley of the Kings. The golden mask sits behind glass in Cairo's Grand Egyptian Museum. The younger lady lies in her vitrine, still nameless after more than a century. The KV-55 skeleton, whoever he was, stares from empty eye sockets in a climate-controlled case. And the two tiny coffins, each containing the remains of a daughter who never took a breath outside the womb, sit in storage, waiting for the next generation of technology to read what their bones still hold. What the DNA revealed, even with all its uncertainties, fundamentally changed what we understand about this family. This was not a dynasty of golden warriors and powerful queens gliding through monumental halls. This was a family trapped by its own theology, marriage practices driven by a belief in divine bloodlines, producing children whose bodies paid the price. A boy with a ruined foot, leaning on a cane, fighting off malaria, burying his stillborn daughters beside him, dead before he turned 20. If this hidden chapter of history intrigued you, subscribe to explore more mysteries that the evidence is only now revealing. The question that remains, the one that next-generation sequencing might someday answer, is the simplest one of all. If the younger lady is not Nefertiti, then where is Nefertiti? Her tomb has never been found. Her mummy has never been identified. She vanishes from the historical record around year 12 of Akhenaten's reign, and no one knows why. If she is the younger lady, then she has been lying on a museum shelf for over 100 years, unnamed, while the world searched for her. Either way, the most famous queen in Egyptian history is either lost, or she has been right in front of us the entire time. Which possibility unsettles you more?